Let's look at statistics and calculating mean and standard deviation. A reminder of different averages. Now, an average is a measure of central tendency. That's the definition of calculating an average. And there's three different types of averages that we can use. The first one is the mean, which is the one that we're going to be using today. And that's where we add up all the data and divide by how many bits of data that we've got. And that gives us a value called the mean. The median we find by putting the data in order from highest to lowest, or lowest to highest, and then finding the middle value. And the mode is the one that appears most often. We can also consider the spread of the data, how consistent it is. Now, we're going to be looking at standard deviation for this, but the most basic form of calculating the spread or how varied our data is the range of the data, which we find just by simply taking the highest value and subtracting the lowest value. Now, the larger the range, the more varied the results. And the smaller the range, the less varied the results, which will also apply to standard deviation. Okay, so let's look at a quick example. So the mean, median, mode and range for a set of data. So we've got a very small set of data, 6 values in this data set. The mean, we add them all up, which gives us 48, and then divide by 6, and that gives us a mean of 8. The median, we have to put them in order from the lowest to the highest. So the lowest value is 1, up to the highest value of 14. This is very important. You cannot find the median without doing this first of all. And then we can see that the middle value is actually falling between two values. It's falling between 7 and 10. Which would be halfway between those. So the easiest way to work out halfway between two values is add them together and divide by 2. So 17 divided by 2, which is 8.5. And the mode, there's 2 14s and one of every other value, so the mode is 14. Now notice a difference there in our values. We've got the mean and the median, which are quite close together. They're 8 and 8.5, but the mode is 14. Now, when we consider the definition for average as a measure of central tendency, 14 is actually the largest value in the data set, so it would not be a good value to use, a good measure of average to use in this particular data set. And that's what you've got to bear in mind when you're looking at statistics. And just because you can work it out in one way doesn't necessarily mean that's the best measure to use. Okay, so the range for that data set as well, 14 minus 1, the largest minus the smallest is 13. Okay, so let's take this forward and look at standard deviation, because standard deviation is a much better way to calculate how varied the data is. Much more involved than the range. The range only used the two extremities of the data. However, standard deviation is a formula that uses every piece of data in your sample. Okay, so when you get your result for standard deviation, it's a value, and the larger the value, the more varied the results are, the more varied our data is, and the smaller the value, the less varied our data is. Okay, so there are two formulas for standard deviation. One's just a variation of another. They both give the same value. However, we're going to just concentrate on how to work through one of these formulas. You're given the formula on the formula sheet. You don't have to learn it, but you do have to know how to apply it effectively. So it does look a little bit confusing to start off with. You have to understand what all these values are, and the best way to understand the values is just to work through an example. But we'll go through what all the different terms are in our our formula. So S is our standard deviation, and then we've got X bar, this X bar, and that's how we say it, X with a little bar on top, is our sample mean. And then we have this big symbol here, that is sigma. It's a Greek letter, sigma, but it means the sum of or the total of. And N is just the number of the values in our sample, okay, in our data set. So we take all that and we have to use that to try and get a value. And the best way to do that is by creating a table of values. So we'll look at an example to see how we do that. So here's an example. We want to find the standard deviation of the following data. So we've got this data listed here. It's just all in order for us, which is great. So 1, 3, 3, 4, 5, 5, 6, 7, 7 and 7. There's no context to this example. It's just a case of being able to work through and work out that standard deviation. So let's take those values. I'm just going to put them up in the top left hand corner. And what the best way forward is to create a table. Now I'm going to write my formula so that I know what I'm working towards. So what we do is we need to understand what the values in this formula are. So the top line there, that's just one value, it's one number, but we're going to use this table to get to that value because otherwise it's very difficult to find it. So that all this data, they're all the different values of X. So that's going to go in my first column. So we've got X in the first column, and that's all the values in my data set. Okay, so that's 1, 3, 3, 4, 5, 5, 6, 7, 7 and 7. And then what we're going to do is from each of those values, we're going to subtract the mean. Okay, that's where the X minus X bar comes in from. Okay, so that's our second column. We're going to subtract the mean from each value individually. And then in the third column, we're going to take whatever value we get and we're going to square it. And that's what's going to happen there. So we need to work our way through this table, and it's not a quick process. You just have to take your time and work through it. So the first thing we need to work out then is what X bar is. What is the mean of our data set? And remember, to find the mean, we add up all the values. So that's the sum of X, add them all up, which comes to 48, and divide by how many values we've got. Well, there's 10 of them, so 48 divided by 10 is 4.8. That is the value for X bar. So we got that from 48 divided by 10, and the 48 comes from just the sum of that column. So what we're going to then do is subtract 4.8 from every value in this table individually. So 1 minus 4.8 is minus 3.8, 3 minus 4.8 is minus 1.8, and so on. So we get these values. So, and it's these values here, whatever these are all equal to, that are really important. And notice that some of them are negative and some of them are positive. That should be the case for this column, because the mean is the center of the data. So some values will be above the mean, some values will be below the mean. So when we subtract, we should get roughly half negative, half positive. But we don't want to use a negative value. It can distort our results. So to get rid of a negative, we square the number. So remember, when we square a number, it should always, if it's a negative, it should always become positive. If it's a positive number, it will just stay positive. So any number squared is always a positive value. And to make sure the calculator is doing that, then put brackets around it in the calculator. So bracket minus 3.8, close bracket, and then press the square button. And we get all of these values. And you check that in your calculator. And the important number at the bottom is the sum, the total of this column here. So that's the number that we're going to use for our formula. So the total, our sum, which is sigma of X minus X bar all squared, is where we add up all these values and we get 37.6. So 37.6 is the number that we're going to use in our formula. So our standard deviation is going to be the square root of 37.6 on the top, and then on the bottom it's n minus 1, so there's 10 values, so minus 1 is 9, and to 2 decimal places that's 2.04. So that's the standard deviation calculated for that data set. Let's have a look at another example. So another actual 10 values here, so this time in the 60s, and we're going to first of all put them all into the first column, so all of our data that we've been given, and they just go straight into a column for X. Each of them is a value of X. and then we need to just write down our formula there. And we're going to first of all find the mean. We can't do anything without having the mean, so add up all the values, 646 when we add all these up. And again, there's 10 values in this data set again, so divide by 10 to get 64.6. So for each of these values, we're going to subtract 64.6 from them. So this time, notice I've not bothered having the working there. I've just put the answer straight in. 60 minus 64.6 is minus 4.6. 62 minus 64.6 is minus 2.6, and so on, all the way down. And then in our final column, we're going to take these values and we're going to square them. And we should always get positive answers in this column. That is the reason why this formula does square them. So we add up all this, and that gets us 44.4. So 44.4 is the value we're going to put into our formula. N minus 1 is 9, so we get the square root of 44.4 over 9, which to 2 decimal places is 2.22. So it's just about practicing applying that formula, practicing these tables, and being able to accurately work through the table to get your answer at the end. So let's look at an example where it's in context. So we've got an example here where we've got the cost of an MP3 player in 6 different British shops. So we're given all these different costs. So 6 different shops have 6 different prices of £66, £55, £70, £53, £61 and £55. And we want to calculate the mean and standard deviation. And we do that exactly the same way as we've just done with our 2 examples. And then we'll look at part B where we've got to compare. So first of all, let's just go through finding our mean and standard deviation. And we don't need the pound sign when we're doing that. We just need the values, the numbers. So for our X column, I'm taking all my amounts here and I'm putting them into this. Notice there's no pound sign. We don't want that when we're just working out the values. And then formula written down there, it should be there in front of you. And the first thing we need to do is work out the mean. Okay, so add up all our values in that first column. So it's the total of all our values is 360. This time there's 6 values, so dividing by 6 gets us 60. So £60 is the mean cost, the average cost of the MP3 player. And then we need to go forward and work out our standard deviation. So we're going to X minus X bar, should have a bar there. So 66 minus 60, 55 minus 60, 70 minus 60, and so on. And we get 6 minus 5, 10 minus 7, 1 and minus 5. And then we're going to square these values. So 36, 25, 100, 49, 1 and 25. Remember, should always be positive. Okay, if you put it into the calculator and you get a negative answer, it's because you've put it into the calculator incorrectly. So what we need is the total of this last column. That's the number that goes in our formula. So we add up that and it gives us 236. So there are 6 data values here, 6 different costs. So n minus 1 will be 5. It's 1 away from that and we do 1 away because it's a sample. So 236 in the top, 5 in the bottom, square root of that, and we get 6.87 or £6.87 for the standard deviation of the cost in the UK shops. Okay, so that's us just worked out in exactly the same way, the mean cost and the standard deviation for our 6 different British shops. So part B then wants us to compare these because it's in context. We would then want to do something with that. Why are we working these out? Well, we want to make a comparison, so between the British costs and the Italian costs. So now the comparison should be 2 different things. So one comment should be to compare the average of the data sets. So that's our mean values. And one comment should be to compare the variation of the data sets, and that's using our standard deviations. So for this, I've just listed again are different values. So the UK ones that we worked out there was a mean cost of £60 and a standard deviation of £6.87. And in Italy, we're given that information. We're given that the mean cost is £55 and we're told that there's a standard deviation of £2.60. Okay, it's been put into the same currency so that we can compare. So our first comment compares this mean of 60 and £55. Okay, so on average, the MP3 player costs less in Italy, or on average, the MP3 player costs more in the UK or Britain. Something like that, but it should specifically say the average. Okay, you cannot just say that it costs less in Italy. Not every single one of them will. This is just about our average. That's all we can say about that. And then the standard deviation looks at how varied the costs are for this particular context. So for here, we could say something like the costs in Italy are less varied. Remember, the larger the value, the more varied. The smaller the value, the less varied. So either the costs in the UK are more varied or the costs in Italy are less varied. But you do have to make sure you're putting it into the context of the question. So if, in this case, we're talking about costs. If you're talking about test scores, then it should be in the context of test scores. If you're talking about weights, it should be in that context. You must apply your comments to the context of the question, and you do not put the mean score is and the standard deviation in Italy is less. That doesn't, it should always be in context, and it should always be in those sort of simple terms, what that actually means by working out that standard deviation. We're talking about the variation of the data.